Hi, sixth grade. Welcome back. I hope you guys had a nice break. Um, Even though I know most of you probably didn't get to go anywhere and the weather was kind of crummy, at least we all had a little bit of a break from school and um, hopefully got to sleep in and watch some movies. Um, okay, let's get going on our next section. So, just as a heads up, I am not planning on having any other major tests this um, quarter for as long as we are learning at home. If we do go back to school, then I will reevaluate it at that point. But from a distance learning perspective, we're not going to have any more major tests. We will have open note quizzes still, and I'm going to start doing Edpuzzle questions embedded in the videos for classwork grades to make sure that everyone is reading and understanding my videos. But that's where we are going to go moving forward. So we are going on to chapter 7. I've posted the pictures of the book online. So please make sure that you go on, and I'll show those in a moment. But please make sure you go on to our classroom and look at the images of my book and highlight and annotate the book um, as I have up on classroom. Where am I? Sorry. All right, let me get into your classroom and then we'll begin. This shouldn't take super long. It's a pretty quick section. We're going to start talking about matter now. Um, the chapter on energy transfer we're going to skip and do next year as seventh graders. It'll work better with the curriculum that I teach in seventh grade, and I'd rather I'd rather us be face to face when I teach it to you. All right, so chapter 7. See here, I posted my book images. Like I said, make sure you go in and highlight yours. Let's go through my Google slide presentation. All right, so as I said, chapter 7 talks about matter. And the first thing your book does is it goes and defines matter. So what is matter? Matter is basically anything that has mass and takes up space. And we oftentimes think of matter as being something that you can see and feel, like a solid or a liquid, but gas is also matter. So I think many of us don't think of gas as being a matter, but gas is a matter, and because gas molecules do have mass. Um, Matter has many different properties or characteristics that we use to identify it and classify it. Um, and we will look at some of those in this chapter. And really, this is the beginning of chemistry. We're starting to look at what is chemistry, what do we learn about in chemistry. We'll touch more on chemistry next year in seventh grade with the periodic table and how do atoms bond together to make molecules. We'll actually touch a little bit on that in this chapter, but we'll do it more extensively next year. But chemistry is basically just, I think sometimes we think of chemistry as being the study of chemicals, and chemicals are matter, but chemistry is a broader study of just matter and how matter changes and how different matter interact with one another. So the first thing, once we've defined matter, your book talks about this notion of a substance, or you might hear it as like a pure substance. And what is a substance? So a substance is a single kind of matter that always has a specific composition. What does that mean? It means that it is always, no matter where the matter originates, who makes it, how it's formed, it always is composed of the same atoms in the same proportion or amount. Okay, so these, I'm going to highlight them in different colors actually to clarify that. So here we have the same atoms and we have the same proportion or amount of those atoms. All right, so the example I give you to the right is table salt. Many of us remember that we've talked about table salt has the chemical formula of NaCl, which is sodium and chlorine atoms. When you combine them together into salt, the name becomes sodium chloride. And no matter where salt is made or how it's made, sodium chloride salt is always one sodium atom bonded to one chlorine atom. So therefore, table salt is an example of a substance, a pure substance, because it's always made the same way. It always has the same type of atoms, and they are always in the same proportion, 1 to 1. Down here, I specify further. Again, a substance can be a solid, liquid, or a gas, and a substance can be a single element, such as gold. Gold is a substance, and gold is only made up of gold atoms. Gold is an element on the periodic table, AU, and so gold would be an example of a substance that is an element, or it can be a compound. A substance can be a compound, like we just showed here with sodium chloride. As long as this super highlighted statement is true, it's a pure substance. As long as it is composed of the same type of atoms in the same proportion, then it's a substance. And so I give you a couple of examples of substances on the next page. So like we said before, it can be a solid, a liquid, or a gas. So one example of a solid substance would be sugar, or the form of sugar that we think of when we think of table sugar is actually sucrose is the name of it. And sucrose is always formed with carbon, hydrogen, and oxygen in these proportions, 12 carbons to 22 hydrogens to 11 oxygens. And here's an example of what a sugar molecule or a sucrose molecule looks like. Same thing with liquid. The example I used is isopropyl alcohol or rubbing alcohol, which some of you may be familiar with. Like if you have a scrape, sometimes you'll use alcohol to clean it out. Alcohol is also what's used in Purell to disinfect things. And so isopropyl alcohol always has the chemical formula C3H7O. And here's an example of a molecule of rubbing alcohol right here. And then lastly, I gave you a really simple one, carbon dioxide. Carbon dioxide is a pure substance that is a gas, and it's a compound. So carbon dioxide is always going to be one carbon atom in the middle, bonded to 2 oxygen atoms on either side. All right, so that is a substance. The other thing we need to look at when we talk about matter and what it goes into in this section is physical versus chemical properties. Your book does an okay job talking about this. I am going to post a video I want you to watch, and I specify you only really need to watch, I think it's the first maybe 8 minutes. I'll give you the exact time. But I found a PBS video that does a much better job explaining the difference between physical and chemical properties, so you're going to do that for homework. But basically, the difference between a physical and a chemical property is a physical property is a characteristic of the substance or a characteristic of the matter that can be observed without it changing, without that matter changing into another substance. So we don't have to perform any type of experiment on it. We don't have to combine it with anything in order to observe physical properties. You can just see it from the matter sitting there. All right, so some examples of physical properties would be how malleable is it? Am I able to hammer it into thin sheets? How dense is it? What is my mass per unit volume? The color, the texture, how does it feel? The solubility, which says how easily does one substance dissolve in another without being chemically changed. Remember, we've talked about dissolving substances before, like if you take sodium chloride, you can dissolve it in water, you can break the bonds between the sodium and chloride, but we're not changing it into anything different, because once that water evaporates, the sodium chloride bonds will reform, and again, the salt will reform in the container. So when we talk solubility, we're not changing it into anything else. We're simply dissolving the bonds, and once the water that has dissolved the bonds either cools or evaporates, the substance will reform. Mass is another example of a physical property, odor, as well as melting point and boiling point. So again, you may want to think of changing ice into liquid water as being a chemical change or a chemical property as to when that happens. But that isn't. It's not, that is a purely physical property, a purely physical change, because in both instances, it's water. It's just water as a solid and water then as a liquid. So it's in a different phase, but it's still water. It hasn't turned into anything else. All right, a chemical property, on the other hand, is a characteristic of a substance that describes how it interacts with other substances. So in order to determine the chemical properties of a substance, oftentimes you need to perform experiments or allow it to interact with other substances in order to observe the chemical properties of that substance. So some examples of chemical properties would include what is the reactivity of the matter, or how easily does it interact with another substance. So one type of reactivity that we're all probably familiar with is corrosion. Most metals, when they come in contact with oxygen and water in the air, will corrode, will rust. And, cars don't do that now, but when I was younger, the way that they painted cars wasn't quite as sophisticated as it is now, and so cars, the metal that makes up cars, was much more susceptible to corroding, to turning into rust as it reacted with water and oxygen that was in the air over the years that you had the car. So now they have a way of protecting the metal in the cars a lot better than they did, say 30 years ago. But that was something that was pretty common to see. Combustibility talks about how whether or not a substance will burn. Flammability talks about how easily will it ignite, how easily will it catch fire and burn. So something can be combustible without necessarily being flammable. When you think flammable, think something that easily and quickly catches fire and burns vigorously. Combustibility just means it has the ability to burn. And then acidity talks about whether or not the substance is an acid. All right, let me see where I'm at in the video. Okay, I got a couple minutes. I just want to quickly look at your book pages. Remember, please go on and do make sure you're highlighting your book where I have it highlighted and filling in the activities. All right, so here they just talk about matter and chemistry and what a substance is. That was on the first page. We just discussed all of that. Make sure you go through these examples. All right, so one of the physical properties they're talking about here with metal is the ability that it's bendable. And so it asks you here, what objects are flexible? Well, an aluminum can you can bend, copper sheeting, a spoon, and what they all have in common is all those objects are metal. And so metal has like a bendability that something like brick or glass or wood doesn't. Let me see what else. They talk about, here's an example of corrosion with rust. And then they talk about your boiling point and freezing point. And then over here, we talk about, here again, they're talking about just phase change from a solid to a liquid. So that's a physical property. And charcoal burning. So when I have charcoal burning, this is a chemical property. This is combustible. In fact, charcoal is, I would classify as flammable. It's pretty easy to light. And again, it's a chemical property of the briquette that it's flammable. But then what we're seeing here is a chemical change happening, and that's what we're going to get into, chemical changes. All right, so make sure that you've done that. Make sure that you watch the video that I post from PBS and fill in the Google Doc and turn it in by Wednesday. And then we will have Zoom class on Wednesday from, let's find the schedule. We will have Zoom class on Wednesday. Course 1, you are at noon, and Course 2, you are at 12:30. So use the link that is posted on Classroom, and I will see you guys then. Bye.